Hello, sixth graders. It's time for our probability review. Okay, the first learning target for probability is likelihood. A lot of times we'll use words such as certain, impossible, likely, unlikely, and equally likely to describe what's going to or expected to happen. And then we'll move on to making it more exact using numbers like a percent, a fraction, or a decimal. So first, we're just going to describe the probability in those first words. On the test, it's going to be a matching section. So a number, that should say is spun. A number is spun. Well, I noticed that there is a letter here, but all the rest of these is numbers. So the chance that I spin a number is probably going to happen, right? So I'm going to say that is a likely event. A likely event is something that is probably going to happen. It has a more than 50% chance of happening. Okay, a letter is spun. Well, there's only this one letter, and all these other sections are numbers. So could it happen? Absolutely. So it could happen, but it's unlikely. It has a less than 50% chance of happening. A number, a letter, or a line. Now, typically we don't even consider that it could land on a line, so don't use that what if situation. But a number, a letter, or a line is spun. Well, it's going to be one of those things, right? So we're going to call that certain. Now, again, we could say, oh, what if the spinner flew off and it didn't land on any of those things? Well, that's kind of like a what if situation, and we're assuming that this is a functional spinner, so these are our choices. In the future, though, just so you know, we are not going to consider the line as an option on a spinner, even though that does sometimes happen. Like if you were to do it in a game, you'd spin again and you'd end up with a different result. Okay, in odd numbers spun. Well, I've got 1, 2, 3, 4, 5 odd numbers out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's exactly half. So if it's exactly half, then we say that's equally likely. And lastly, the number 11 is spun. Well, I'm looking and I don't see the number 11 anywhere. So we're going to call that impossible. So if it's impossible, that means it's a 0% chance of happening, and certain means it's a 100% chance going to happen. All right, I tried to come up with some unique examples here because sample space, we've used pretty much all of them so far. You're going to have a little bit more normal examples on yours. So let's say we flipped a water bottle. Let's say the options are it can fall or it can stand. Now you might be more specific and you might say it could land on the top, it could land on the bottom, it could land on the side, it could land on its edge. I'm going to say it either falls or it stands. Those are our options. Okay, and then the second one, I'm sorry, I should explain this more. Sample space is the full list of everything that could happen. So if I'm looking at this bag of marbles, I could pull out a white marble, I could pull out a green marble, or I could pull out a blue marble. Okay, I can't pull out a red marble. I'm not going to write it down. I'm just writing down the things that are in the bag. All right, the next thing is finding simple probability is just simply taking the number of desired outcomes, the things you want to happen, or the thing that's the probability of happening, out of the total number. You can use a sample space to find that total number if it helps you. Okay, so the first one, we're very familiar with rolling a die. This one, be careful, read the directions. It wants our answers as fractions in simplest form. So if I'm looking at odd, well, my sample space would be 1, 2, 3, 4, 5, and 6. And we got to be careful because sample space doesn't necessarily mean that everything has an equal chance of happening. But in this case, every single thing has an equal chance of happening. So the chance of odd would be a 1, a 3, or a 5. That's 3 out of 6. And in simplest form, that's 1/2. Okay, if I want to know what's the probability of just getting the 3, well, that's 1 choice out of 6 choices, and that's in simplest form. Now, what about a 7? The probability of a 7. there's not going to roll a 7 because it's one die. So that's a 0 out of 6. Or I would accept 0, or I would probably accept impossible since it means 0%. And then a number greater than 2. Well, greater than 2 would be all of these. So that's 4 options out of the 6 options, which simplifies to be 2/3. Here's another one. This one wants us to write it as a decimal. So first I'm going to write it as a fraction and then I'll convert it. So the probability of getting a star, well, that's one choice out of the 4 choices. I can take the top number divided by the bottom number. 1 divided by 4 equals 0.25. That's my decimal. Okay, a lot of you probably know that one. What's the probability that it's not a triangle? Well, there are 1, 2, 3 things in there that are not triangles out of a total of 4, and that 3 divided by 4 is 0.75. And the last one is asking us to find it as a percent. Again, I'm going to start with the fraction, and then I'll convert it. So the probability of white, well, there's 2 white ones out of a total of 5. I want this to be out of 100 because percents are all out of 100. So I can go ahead and crisscross multiply, divide by the lonely guy. I could take 2 divided by 5 and then move the decimal point over 2 places. I'm going to go ahead and say, well, this is times 20. So I'm going to take this times 20, and that is 40 out of 100, or 40%. And the probability of black, well, there's 3 black ones out of a total of 5. Again, I want it out of 100 because that's what percents are. Again, I'm going to multiply times 20 and multiply times 20, and that is 60%. These two are complements of each other because the two things together add up to 100%. All right, then the last section of the test is about experimental probability. I just have a few examples. So we're going to use someone else's experiments data and we're going to apply it to the future. So we're going to assume whatever already happened is going to happen at the same likelihood. So Maddie and Claire are partners in a bottle flipping competition. The table shows their practice results. If they get 100 attempts in the competition, how many would you expect to stand? Well, first let's find what's the fraction of ones that already are standing. So we've got 8 out of 5, 10, 15, 16, 17, 18, 19, 20 out of 20. Okay, so I want to know what it would be out of 100. So I could just crisscross multiply, divide by the lonely guy, or I could say times 5. Times 5, and that's 40 out of 100 is what I would expect. Okay, the next one, Sam likes to throw grapes in the air and catch them in his mouth. If Sam catches 9 grapes in 25 tries, what is the percent chance that he will make his next attempt? Well, I'm going to write it as a fraction first. He makes 9 out of 25, and I want to change this to a decimal. 2 ways I can do that. One, I can make it equal to something out of 100, crisscross multiply, divide by the lonely guy. Or I could take 9 divided by 25. That will give me the decimal. Move that decimal point over 2 places. Whenever the number is a friendly number, I like to just use my brain and multiply it out. So this is 36 out of 100. Out of 100 is the same as percent. So 36%. And the last one. The hair color of customers is recorded as they enter the store. Using a simplified fraction, tell the likelihood that of the next customer having red hair. So again, I'm going to look at what I have here. I'm going to write it as a fraction. I will simplify my fraction, and then I'm done. So red is what I'm looking at. So I'm going to do red as the desired outcome over, and I'm going to add these up. So I've got 15, 25, 35, 36, 37, 38, 39, 40, 41, 42, 43. 2 out of 43. Okay, so 43 is a tough one. It is actually a prime number. You cannot divide it by anything. So 2/43 is as simple as it gets. That is the fractional chance that the next person will be a redhead. All right, I hope this was helpful. Have a great night.